A-level maths, paper 3 was the bane of my existence, yet it was my best A-level paper. I got 98% in that exam because I only lost 2 marks. And better than anything, those 2 marks were on probability. Possibly the easiest topic in the paper. Lo and behold, I didn't read the question properly. Today I'm going to be telling you things that nobody's ever told you before about A-level maths paper 3, my top study tips and best pieces of revision advice to help you get that A star. A-level maths paper 3 is very different to any other paper that you will sit in any A-level, and I want to help you get the best grade you possibly can. If you find this video helpful, be sure to like and subscribe and show your support. Hello everybody, welcome back to my channel and welcome back to another video where I'm giving you my top study tips and tricks for A-level maths. You guys loved the last video so much, I knew I had to make a video specific to paper 3. As I hope you all know by now, A-level maths paper 3 is statistics and mechanics. These 2 sections are very different, and for that reason I used to study for them in isolation. So the first thing I want you to understand is that you don't need to allocate the same amount of time to revising both sections. Certain students will be better at statistics, certain will be better at mechanics, naturally. However, in maths, this is a weird perk and a weird disadvantage that some students have. Those students doing A-level physics are usually naturally much better at mechanics. Those students doing A-level further maths are usually better at statistics if they take that, or mechanics if they take that. People doing A-level statistics like I did are usually much better at statistics. So most of my revision time for this paper was on mechanics. The first thing that needs to be said about this paper is that you don't need to revise everything. There are stupidly easy topics, as in correlation. I have no doubt in my mind that any A-level maths student can look at a graph that has a positive correlation and tell me it's a positive correlation. However, that being said, there are ridiculously difficult topics in this paper as well. Think modelling with static particles. Think integrating vectors. I feel like the range of difficulty of topics in this paper is more so than any other A-level maths paper. So I want to give you some tips about revising the different sections, and we will start with statistics. Statistics was my best section. Well, it wasn't in the actual exam because I lost 2 marks in it, but I found it the easiest because I did an A-level in statistics, so I've got quite a lot of practice using stats. Basically, statistics is all about understanding why you're doing what you're doing, because if you don't understand why you're doing a hypothesis test, it becomes incredibly difficult. You have no intuition of why you would ever accept or reject, why you would write a hypothesis in the way in which you do. The thing that trips people up in the statistics section is not understanding those core fundamental concepts before going on to the next thing. So you will be told basically instantly a discrete distribution is where x can take a set of values, or a continuous is it can take infinitely many different values. Okay, what's the probability that x equals some number in a continuous distribution? It is 0. You can memorise that. Anyone can memorise that. But do you understand it? It's just like in pure maths. You can be told that any number to the power of 0 is equal to 1. Easy to memorise. But why? Does it make sense? And this might sound all, oh yeah, sure, whatever. But if you just remember, what's the point? If you don't understand those core concepts, that continuous distribution, you are just not going to understand anything about the normal distribution. And then standard deviation, when you move on to the normal, it's one of the core concepts you need to understand in the stats part. And people just don't get it. Like, so many people don't understand it. Variance and standard deviation is not some magic number. It's really hard to understand, but if you use the definition, as in the standard deviation is the measure of spread of data around its mean. Again, you could just memorize this. However, if you don't understand it, doing things like hypothesis testing is going to become very difficult. So those facts, like 67% of the data falls within 1 standard deviation, 95% falls into 2, and 99.7 falls into 3. This makes so much sense when you're doing hypothesis testing. Sorry, this will make hypothesis testing make so much more sense. I don't want this video to be 30 minutes long, so I'm not going to bang on about stats for too long, but some more key things I need you to understand is that the large data set It will be worth 3 marks. It's usually worth 3 marks. Please just remember it. There's no way to get around it. You could just sacrifice those 3 marks. However, they're 3 easy marks. Just remember it. I had a big mind map of all of the information we needed to know, particularly the units. That is very important to remember. They like to ask about that. And they like to ask something rogue as well, something about like cloud coverage. And again, Venn diagrams, there's no way to get around that other than just remember it. So, you know, A union B, A and B, A dash, B dash, that kind of thing. With Venn diagrams, always draw a box around it as well, otherwise you will lose a mark. Right, let's go on to mechanics. This was by far my weakest area of A-level maths, and I still got 100% in it. You need to start from those things that you misunderstood first, because if you don't understand the SUVAT equations, you are done for. You need to understand that before you do anything else. Be able to derive them, understand what they mean, and get your head around those basic concepts before you try and do more difficult things. So please do the basic examples before you move on to the harder ones, because A-level maths progresses really quickly, particularly the mechanics section, because right, schools tend to be really good at teaching pure, but then when it comes to stats and mechanics, they do it differently. Some do a bit in year 12, a bit in year 13. Some people just shove it all at the end of year 13. Paper 3 is not actually taught very well on average. But the point is, with mechanics, you really need to visualize what you're doing. So when you have friction, when you have tension, when you're talking about like pulleys and stuff, you need to be able to visualize it. Imagine, okay, when I drag my hand across my other hand, there is a force acting upon it. It is tension. Also bear in mind that for mechanics in particular, you need very strong foundations in pure maths, because you are doing things with vectors, with differentiation, with integration. And once again, it's about understanding why you're doing what you're doing. So let's take integrating vectors. You integrate with respect to time. Why are you integrating with respect to time? What does this show? Okay, this shows you as something changes over time. And again, the reason that I did so well in the mechanics is because I spent so long getting my head around something. If I didn't completely understand something when I left a lesson, I would be sure to go home and finish off the practice questions. I would watch YouTube video after YouTube video after YouTube video until I got it, and it didn't come naturally to me. And that is just what you have to do. Not just sit there and do the practice over and over again, plug numbers into the SUVAT equations, you know, use that equation of a trajectory formula. It's pointless if you don't know why you're doing what you're doing, because then you will have questions that are going to say, oh, give an example of why the model wouldn't work in real life. So many students get these wrong. I used to find these were the easiest marks though, because it was like, it just made sense to me because I understood why I was doing what I was doing. But for mechanics as well, they will always throw something completely unhinged at you. They will throw a really hard question at you. So do all of those challenge questions in the textbook. There are challenge, that's upside down. There are challenge questions, do them. And watch videos on how you solve them online. The textbook online version has steps on how you solve it. Use that, don't just use the answers in the back. And then with statistics, they don't necessarily put a ridiculously hard question in, but they will put a misleading question in normally. They are trying to slip people up. You need to be very careful about the wording of each question in the stats section. And final pieces of exam tips, make sure you give your answer in the form they want to see it in. Be careful with units. Your hypothesis test conclusions, you cannot say anything is for certain. You need to say we reject the null hypothesis because there is insufficient evidence to suggest that. Not just saying we reject, it's false, but you can't say that. That's not what a hypothesis test is. Be careful with units in mechanics, as in meter squared, centimeter squared, kilometer squared. And do not spend loads of time on the stats section and neglect the mechanics part. If you found this video helpful, be sure to follow for more daily study tips, and best of luck in that exam.